Thanks for joining, everybody. I'm Greg. I'm co-founder and CTO and I guess CEO and whatever at Undo. And we're going to talk today about all of the good new stuff in GDB 9 and GDB 10 and actually 11, because that was released after I'd submitted this talk. So I'm going to go cover some of the sort of basics as well. So I'm assuming you know about GDB if you're here. And you just want to see kind of what's new, but I won't assume prior knowledge with the new advanced stuff that we're going to talk about. If anybody has any questions, please raise them through the normal chat anytime. I'm always find these things work better the more kind of interactive and flowing they can be. And if I go completely off topic and don't follow the slides at all, that is a good thing in my view. All right, so without further ado, some of the things we are going to look at today include, not exclusive, but we're going to talk about Debug InfoD, new stuff with user-defined commands, stuff around backtraces, and some of the sort of later Python integration stuff. So before we go any further, I've got a little poll. And so I'm going to raise the poll now just to get a sense of kind of the audience here and that and see if everybody's kind of see kind of where we are. So I'm going to launch the poll now. The first question is, have you used GDB's Python integration at all? And then the second one is about how you actually access the GDB, what your preferred GDB UI is. So let's just take a minute or so just to answer these questions around. So do you ever use the Python GDB integration? And do we like to use through the CLI or TUI mode or VS Code, C-Line, Eclipse, Emacs or other? Okay, so we're getting some votes coming in. Emacs off to a slower start than I was expecting. I see quite a lot of that. A couple of others, so we've just got 4 on Emacs. CLI is winning, that's interesting. And VS Code in second place. It's very exciting watching these polling numbers come in. It's like way better than election night. So on the preferred UI, seems to be stabilizing there around about a third using the command line interface. Second place VS Code on 22%, and we have C-Line not far behind. So I'll publish the final results later. And in terms of have you used GDB Python integration, okay, most people haven't actually. So a sizable minority have at 28%, but most people have not used the Python integration. So I'll do a little bit of kind of background around that because it's amazing what you can do with it. So we'll maybe do some sort of basics there when we get to that point in the talk. Right, so let's start with, we're going to talk about Debug InfoD, which is this pretty cool thing that's just come along. And so let's start with our debugging sort of basics. So, when you type GCC or clang -3 hello.c, always -G3, because that just gives you extra debug. It's my little top tip, just gives you extra goodness. What do you get? Well, it produces a file, obviously. And if you just do that command line, you're going to get a file called a.out. And that's going to contain a bunch of sections. Now, this is a simplified version. The reality is more complex, but we have the text section, which is basically code. I think just gets called text for historical reasons. I think data section is what you might imagine. But RA data, read-only data, so strings, consts, and a simple table and some debug info, and actually a whole bunch of other stuff. So let's just have a look at what that looks like. So let's make that a little bit bigger. So here's hello world.c, and so we can compile hello world.c, and we get a file called a.out, of course. So if I go readelf --sections a.out, I'll put it through this. So you can see here are all my sections in that a.out file, right? It's an elf file, of course. It's got a bunch of sections. So there's my text section, right? That's the program. So we can see that's hex 1060 bytes big. So hex 1000. So that's basically a page. Here's RO data. And here's data a little bit further down. And here's our debug info. Look, debug info there. And just a few lines down, section number 34. You can see there we've got our symbol table, right? So actually a whole bunch of sections, but for our simplified version today, those will do. All right, so all good. But what does that actually? How do we like debug that? What happens on? Well, in fact, before we get to debug that, what happens when we run it? So a.out is a file, right? It's an executable, of course. When I run that file, what happens is a whole bunch of these sections. So it's a file that lives on disk, and when I run this, a whole bunch of these sections get mapped, right? Process gets created, it's now virtual memory, and a bunch of these sections from the executable file get mapped into that process's address space, along with some other maps for heap and stack and BSS and whatever. Okay, good. We got a good tip come in there for readelf -w. Didn't know about that one, so let's have a look at what that looks like. Maybe that's a bit better. Readelf -w. Oh yeah, look, that's nicer. There we go. So we can see them all in one go. Cool. Right. So here's so this is when the process is running. We've mapped a bunch of these sections in. Notice we have not mapped in the symbol table or the debug info. That just stays on disk. Now, actually, it depends on the kind of executable you have. By default, on x86-64 Linux, these will be relocatable, position independent. Program, so they can just get mapped in without having to relocate the text. But on other, I think by default on 32-bit x86, you'd probably get relocatable image. So all the symbols would have to be patched up to where the loader is actually loaded into memory. So the symbol table would be needed. But debug info still would always just stay there on disk. But when I'm running the debugger, GDB in this case, well, it's going to map. Well, not map, but access all of the process memory. So when it wants to know what code is running and everything, is just going to look at the process, because maybe it changed, right? Maybe I've got self-modifying code or whatever. So it's not going to read. It's not going to read the kind of the program contents from the file, but it is going to read symbol table and it is going to read debug info straight out of the a.out file, right? Because that isn't in memory. In my really simple case that I'm doing here of GCC, we run GCC and I'll come run GB, and of course this all like just works, right? It's because my source code is there on the and a.out is there, and GDB can just find everything it needs to give me that that sort of symbolic debugging that we know and love, right? All good, but maybe I don't want that debug info all the time, right? Why might I not want the debug info? Well, there's a couple of reasons. One, it can be kind of large. So for a demo I'll show later in the talk, I have installed on my system the Firefox debug info, right? So it's probably a better way to do this, but I'm no apt expert. But if I remove the Firefox debug info, going to tell me that 465 megabytes will be freed up. I don't actually want to remove it. If I say let's remove Firefox, so this Firefox is going to remove Firefox and the Firefox debug info, and the whole thing together is less than 700 megabytes. So actually, the Firefox debug info is bigger than Firefox, right? And so it's for big programs it can get pretty big. Especially if you do with -G3, as I sort of generally recommend, but that does make the debug info even bigger. So that can be a lot of stuff to carry around. For example, if I'm, making Docker images and I want to kind of, make them compact to deploy quickly, or I'm just shipping my software, right? So when people download Firefox from their distribution repository, better just to download the, couple of hundred, also 230 megabytes than download the whole 691 megabytes. So we don't always want the debug info hanging around, or maybe it's more of a kind of IP kind of sensitivity thing, right? I mean, a lot of our customers at Undo are folks like EDA companies, or database companies, and for good reasons, they're very, very kind of sensitive about their IP. They don't want their competitors to be rooting around inside their code trying to figure out what it all does. And if you've got all the debug info with all of the structure names and layout and everything, then you can actually determine quite a lot. So for lots of reasons, just carrying around your debug info inside your executables is it may not be what you want. So you may want to separate it out. There's a few ways you can do that. Probably the simplest way is one at the top. So we can just copy a.out to a.out.dbg and then strip it, and then that will get rid of all the kind of stuff that we don't need in order to run. Or we can use obj-copy. Obj-copy be a little bit more kind of precise about exactly what I'm going to take. So I'm going to use the first method because it's just simpler. So I'm going to copy a.out to, I'm going to call it whatever I want, but I'm going to call it a.out.debug, and then I'm going to strip a.out. So yeah, so when we strip a.out, so let's have a look at these two files. So you can see I was playing around before. Let's get rid of that. Just make this clearer. So a.out is considerably smaller than a.out.debug. I mean, it's still small, but 14K as opposed to 41. And let's have a look at read elf, remembering that top tip you were just given. So what's in a.out now? Yeah, fewer. Remember, there's 30-something sections before, and no debug info in there, right? Cool. So now I've got two versions of my file. So if I now run, of course, you'd be unsurprised if I run GDB through a.out. It says no debugging symbols found, right? There's no. By the way, I think there's often people sort of conflate symbols and debug information, and they kind of get treated as kind of one. And I like thinking of kind of different things. So symbols, where's my main symbol? Well, there is no symbol. There are no symbols here, and there's no debug information either. So if I try and break on main, well, there is no. Even main's not defined, right? I probably have libc. I think I probably have this one. No, don't even have that. So I've got no symbols. I can't even put in breakpoints, and I certainly got no debug information, so I can't get that kind of symbolic debugging. Now I can, from this point, actually, I could just tell GDB like that. Now we probably have symbols, and now I can probably go break main. That looks good. I can run my program, and here we are. So I've got this debug file locally, point GDB at it, that's great. But kind of defeated the object because I've got to have that locally, right? What if I was shipping or deploying or downloading a.out, but not a.out.debug, right? How do I deal with that? And so, what we tend to get in the package management, repositories we just saw with Fox debuggers, that's kind of, that kind of works. But it's problems with it, right? My Firefox debug package had better match my original Firefox package. Otherwise, things get really confusing, right? Like the exact same build. And if I'm sort of got some kind of very well managed thing like a distribution, that can kind of work. But if I've got something like so I'm deploying these Docker images and I don't have debug information and stuff, it's just inconvenient, right? And easy to get wrong, easy to find. You generated the debug information at a certain time, but now you don't know where that is, and you've got a version mismatch or whatever the problem is. So actually, so Debug InfoD is a way we can kind of manage that. Now it's is it really a GDB feature? No, but it's something that the kind of debug for front ends need support for. So this is what it looks like, right? So this is all fairly new stuff, but it's beginning to find its way into repositories. So this is relatively recent Ubuntu that I'm on. So I can go sudo apt install Debug InfoD. It's already installed, right? But you get the idea of how that would work. And so I can just run it, right? Debug InfoD. And I can point it at the file with all the debug stuff in it like that. So cannot start server because that's already in use. All right, that's annoying. Just bear with me while I find out where. So this is why you should never practice. Hang on a second. But also proves that I am actually doing it. Right. No. That's annoying. Oh, that's annoying. I just stopped the wrong thing. I just stop? Oops, I just stopped my Audacity recording now. That's not ideal. Let's restart that. Let's restart that file. Just bear with me. Sorry about this interruption. Right. Okay. There we go. So Debug InfoD has started. Look, it's found some files because I told him about that. Told it about that file. And now what I'm going to do, just get that. Now I'm going to run GDB. So if I run, remember, if I run GDB against a dot, well, so if I run GDB against a dot like that, got no debugging information, right? Can't break on main. Oops. So let's run it like this instead. Debug InfoD URLs equals. Remember, it's just running on my local machine. It told me there that it's running on. Look, it's running on port 8002. So localhost 8002. And oh, look, I seem to have some symbols, and I can break on main and run. And look at that, and I've got source code and everything. Isn't that cool? Well, cool-ish, but I'm kind of cheating because the source code, right? Source code is not part of that a.out, and GDB is only finding the source code because it happens to be right here. So if I let's put that away. Let's squirrel that away, right? So let's move hello.c and a.out.debug into this different directory. So this will still, what we'll see now, I think, is it will have the symbols. Yeah, great. But it doesn't have the source code, right? And now I think there's actually a bugette here in Debug InfoD. It says directory not empty. I think that's some sort of error code mangling. But basically, it can't find hello.c. But that's okay. I can teach Debug InfoD about that. And actually, if I look here at the output I get from Debug InfoD, I get, some of these not found messages. So some debug info it's looking for that's not finding. Talk about that in a minute. But look, it's trying to get the source file, and I didn't tell Debug InfoD where that source file was. Notice it's got the full path here, right? So it's an absolute path. So what I'm going to do instead is let's just momentarily move the source code back, and I'm going to what's the best way to do this? Actually, I'm going to move the debug version back as well. I'm going to make a tar file tbzf, and I'm going to make from my tar file called debug.tgz. I'm going to tar up the source code, and I'm going to tar up the original version. I could have used the object copy thing to get just the debug info, but this contains the debug info and everything else. That'll do for the demo to keep things simple. Good. All right. So I don't think I wanted to do that though. I think what I wanted to do is give it the absolute path name. So bear with me, because remember we saw it as the absolute path. So there we go. So that's hopefully tbzf debug.tgz. There we go. So I've got the a.out debug and the source code in that tar file. So now Control C out Debug InfoD, and I'm going to give it that tarball like that. Okay. So now I'm going to I can get rid of my source code, and for good measure, let's put them in. Temp, and now when I do that GDB again, okay, I've got I'm going to do start, which is just set a temporary breakpoint on main and run. And now what have I got wrong there? I didn't like that. Let's have a look. So home Joe demos. What did I get wrong there. That worked when I was testing it. I'm not going to spend too long because you get the idea. Home journal downloads review hello.c. So I don't know why that hasn't worked. Okay, it worked when I was doing. I've obviously got something wrong, but it worked. It worked when I was doing this before. I'll figure it out at some point. I'm not going to, but not going to do that live. So what else? Well, I also wanted to show you these build IDs. Right, so this is how Debug Info makes sure that it's returning the relevant stuff. So if I look at my, let's go back into here. So if I look at my a dot out, we've got remember read elf dash notes a dot out. Get the big B. Here, so here's my A.out. My A.out has got a build ID. Now, if I look at my, oops. Why didn't that work? DPG, oh, because I, so it's, I know what's going on. That I didn't tar up the A.out debug thing correctly, but so let's see if I can get. There it is. So that's why I didn't give that the absolute path name, I think. Anyway, so read elf dash notes a.out.debug grep build. So here's my build ID here, 4455. Hopefully that's going to be the same. Yes, it is, 4455 blah. And Debug InfoD has been asked to fetch the debug info for that build ID. So there it is. Well, here it's going to get the source for that, but further up you can see it getting the debug info, not found. Anyway, somewhere. Anyway, yeah, so you get the point, right? So these binaries have a build ID in them, which is a unique ID, which Debug InfoD will match against it. So it can be guaranteed that you're getting you're not going to get those nasty kind of mismatch things. And you can tar up, you can give it the tarball that includes the source and the debug info, and it will serve the source, over the wire to your GDB as long as you give it that magic environment variable, right? Cool. So this is actually sometimes you might have heard about the Microsoft symbol server, and sometimes was cited as one of the things that is more pleasant about debugging in a kind of Microsoft land. The Microsoft debugger has had a notion for a long time of a symbol server, and which sort of this kind of provides all of that, but arguably in a kind of nicer way. And it's beginning to be rolled out now. So elfutils has a. By the way, these servers are kind of they can be sort of federated servers, so they can then just go out to other providers. So this Debug InfoD at elfutils will knows about loads of stuff, and many of the distros are beginning to supply these, right? So Debian and OpenSUSE's kind of the biggest ones. Ubuntu not yet, but I think that will come. And we've got client support in GDB, as we've seen, but also in Valgrind and SystemTap. And I suppose ultimately anything that needs to read debug information. All right, that's it for Debug InfoD. Unless there are any questions on anything that I covered there. Sorry, the demo didn't quite work, but you get the idea. By the way, all of this and all of these talks that I do, the idea is they're not a tutorial. I don't expect everybody to come away with the ability to just do all this stuff, but to kind of know it exists and know what it can do, and then know that when you need it, probably, let's face it, sometime from now, you kind of got an idea it exists, so you can start to look up the actual ins and outs of how you do it. Right, so user-defined commands. So there are a couple of ways to do user-defined commands in GDB, and they're super useful, right? So if you're working on a project, largish project with multiple people, defining some user-defined commands can be a really helpful thing to do. You can also do Python pretty printers. We talked about that in a previous talk, and that's up online. That's a useful thing to do for large projects for sure. But user-defined commands are also pretty good. Now, there's two main ways you can do that. You can do that through Python, through the Python integration. As we saw, only sort of a quarter or so of people actually ever use the Python integration, and it's a bit fiddly. Like, it's more flexible. It's definitely kind of quotes better, but it is more. There's a lot more typing to do. There's more boilerplate, and to be honest, I can never remember. So when I need a quick and dirty user-defined command, I'll just do one of the GDB user-defined commands. So super, I shouldn't even need a program to be running, so I just go define, and then I'm going to call it, I don't know, hello, and I'm going to echo hello, and that's it, right? And so now I've got this user-defined command, and it just echoes hello. But it could do, obviously whatever I wanted. I can add online help, by the way, pretty easily. So document hello, and I can write my documentation. So now I can go help hello, and it gives my help. It's quite cool, isn't it? But most GDB commands actually they have a kind of they've got a sort of a prefix and then other things you do. So you usually use multiple words, right? So it might be I'm going to go start. Hang on. It's GDB right, start. So I can go info threads. Got one thread. So I can go info shared library. I can see the shared libraries that I have, right? It's kind of convenient, right, to be able to batch these things together. Apart from anything else, I can tab complete. Info, tab. Oh, look, info on lots of things, right? That's one of the bigger command prefixes. So now I can do that with my user-defined commands as well. So we can go define prefix hello. So that's now I've just redefined that as a command prefix. And then I can go define hello. I can do an English hello, and define hello. Let's do a French hello. So now hello tab. I've got different completions of this, and I can do my English hello, and I can do my French hello. So that's quite good. Little thing, but useful. And actually, the ability to that tab, so you get the tab completion, I think really helps for discoverability. GDB generally is not super discoverable, as command line applications tend not to be. But the ability to poke around commands like that, I think, does help. So that's kind of cool. Nice little thing. Okay, you can put the names in the commands can now include the dot character. It's a fairly minor little feature. I don't think I need to demo that, but well, why not? Nice. The with command. Now, this is particularly useful, I think, inside user-defined command. So inside my user-defined command, I might want to change some kind of setting, right? So maybe, I don't know, maybe things go a bit nasty if my pagination is on. So maybe I go define hello and I want to go set pagination off, and then echo a whole bunch of text, like no, let's just pretend this is many lines long. Fine, right? Well, the trouble is now when I run that command, of course, it's going to have a side effect of setting pagination off. So show pagination is on. So pagination, by the way, is just, if you have more lines, if the command generates more lines than will fit in your window, it'll give you the, the type C to continue or Q to quit or return to see the next page. And that can get in the way sometimes. But so now I've done it like that. Well, run hello, and okay, blah, blah. And now it's turned pagination off, which I probably didn't want, right? Well, I could redefine hello to, yes, I'm going to redefine it. I'm going to set pagination on, echo hello, set pagination off. But of course, maybe I already had pagination on and I wanted off, and I wanted pagin, and so, sorry, I've got that the wrong way around, didn't I? Let's do that. That's confusing, right? Redefine hello. So set pagination off. Echo hello. Set pagination back on. Okay, all good. But maybe I had already set pagination off, right? Now I've turned it back on again. So, oh well, now I need to store the value of what pagination was somehow and reset it as previous state. And oh, that's all kind of hard. So wouldn't it be better if I can go define hello with pagination off? Echo hello, and now, regardless of so set pagination on, hello does that, and now pagination is going to be whatever it was, right? So that's kind of, and I don't have to use the with command inside user-defined commands. I can use it. Maybe I just want to set something without having to set it back again. So it can be convenient as well, just from the command line, but particularly useful, I think, for user-defined commands. Good, right. Here's another little cool little thing, again, useful within user-defined commands, although you can do it wherever you want. There's this little pipe command. Whoops. So if I, what did we do before? We did shared library. Oh, I think my computer's going really slow. Hang on just a second. Okay. All right, follow up. I think my computer just overheated a bit and went on a bit of a panic, but I think I'm back now, hopefully. So what were we doing? Right, yes, info. Close that. Info shared library. Okay, right. So I'm often what's our favorite pipe command to pipe to? It's grep. So I can do pipe info shared library, and then I can say what I'm going to pipe it to, and I'm going to grep that address. So I've only got two shared libraries. Maybe I've got many shared libraries. I'm going to look for an address, and because of that, I can actually, that pipe symbol is an alias for pipe. I can do it like that. So that's quite neat. Again, not only useful from within user-defined commands, but I think particularly useful for user-defined commands. Most of what I'm showing, by the way, I should have said, most of this was introduced, most of the features were introduced in GDB 9. Debug Info is actually introduced in GDB 10. And so you only get that with the newer distros. I'm not sure how widely deployed GDB 11 is yet. Not much. Not much new in GDB 11. Certainly 9 was when the bulk of stuff came in, but we'll talk about one thing in a minute. So everything apart from Debug Info, I think I'm showing today is in GDB 9. So let's get back here. Right. This is a small thing, but I think very useful. So if you see my previous talks, you might know that sometimes GDB can, it's caught me out in the past by calling user-defined, calling functions inside the inferior, and not always when you kind of expect it to. So maybe I'm just doing a print, but there's it could be there could be some operator overloading, right? So I could print A plus B from GDB command line. If there's operator overloading, then we'll go and call that function. Actually, if there's TLS, thread local storage involved, it can go off and call a function. And even actually sometimes GDB, and I think this is surprising enough to be unhelpful, will call malloc on your behalf behind the scenes. If you're passing in if you're doing something with a string, it'll actually malloc space for that string inside the inferior and then populate the string, and then like if you're passing it into a, so if I'm doing something like call strucump, like foo, and I've got a string pointer, I don't know, like that, then it'll actually go and do a malloc. Okay, I've got no symbols here, but anyway, it'll go and it will. Oh no, I can't type. Strucump. There you go. Behind the scenes, that will have gone and done a malloc of 4 bytes and written the foo string, null terminated into that, and then called that function. Which, if you're trying to debug your own malloc implementation, it can be confusing. So it can be a little bit sort of trigger happy, and bad things can happen, and side effects can just cause weird things. So I can go set may call functions off, and now if I try and do that, it will just say no, I'm not doing that. So that's kind of useful. Actually, in GDB 9, I think it is, it won't go and do a malloc for those strings. It does it, I'm not quite sure how, find some spare space and does it in a different way. Actually that malloc for the strings is not true in later GDBs, but it will still nonetheless, the thing about calling functions back if there's operator overloading, or just because you said call, and that might call badness. So that's quite a useful kind of safety catch should you require. Oh yeah, I just said that. Right. How are we for time? Too bad. All right, so here's some other kind of just vaguely useful stuff, bit of control over backtraces. So let's get a backtrace here. What am I going to do? So here I am. I'm going to set a catch point for the write as catch syscall write. Okay, so catch points kind of breakpoint for system calls or other things, and so I'm going to catch call on the write system call, so that when I continue, I can get myself quite a big backtrace. There it is. Here's the pagination stuff I was talking about, right? So I've got a backtrace and I've got a bunch of stuff in there. It's trying to decode, being vaguely helpful, trying to decode, not decode, but tell me what the arguments are. But maybe I kind of don't want that because it kind of gets in the way. So I can do set print frame arguments none, and then do a backtrace. And not bad, still a little bit, but I've got, it's now, just perhaps easier to read. I could actually even get less than that with presence. And now it just says, yeah, there are some arguments, but I'm going to tell you what they are. So it just makes my backtraces maybe more readable, maybe less, depending on what I'm doing. Scalars, you'll notice, so you can just stop it trying to print any, if you're passing in structures or classes. And similar kind of stuff on the frame info, so I can configure. I'm not going to go through all this. You can kind of figure out what this is, and certainly now you know it exists. So if you find GDB's backtrace printing a little bit verbose, maybe not verbose enough, you can now, in the later versions, configure that a bit more. You maybe have noticed. Let's go up. Whoops. didn't mean that, frame 7, back up our call stack. So you might have noticed that if you haven't used newer versions of GDB, this is kind of a little bit pretty, isn't it? Almost. I've got a syntax highlighting here, which is which is kind of nice and vaguely configurable. So I can go set style, tab to see I can actually set the style for the various things, and I can turn it off, and that's good old fashioned monochrome. And maybe I find it gets in the way. So that's there. And the point is, I think we have got syntax highlighting in the newer versions, which is a bit easier on the eye. Small thing, I don't know if you know about the ptype command. I'm relatively new to it actually, but I find it quite useful. So here I've got a file with some structs. So GCC, actually I don't need, just to prove it, I don't need the -G for that. GDB, so if I go, ptype X, it tells me it's a struct, and that's the layout of the struct. That's quite nice. I can actually also give I can give a variable name, or I can give the type, same, right? But one thing that's quite nice about ptype is I can go ptype -O struct foo, and look at that. So it gives me the offset and the size of each of the members of the structure. That's which we all know can be useful sometimes. So that's quite good. Saves you writing a small program with some size of in it. And that's been around for quite a long time, but there's just a small change to it. And so I can do /XO, and whoops, I think I have to go. Oh no, I am probably on to, maybe this is a GDB 11 thing. So ptype -XO. Yes, so in GB 11 I can do /XO or OX, and I get my sizes and offsets in hex, which is more likely to be more likely to be useful, frankly. So that's kind of cool. All right. There are some new convenience variables. So these can be quite, again, if you're doing user-defined commands, for your team, and different people are on different versions. I can GDB major like that. So that's quite good. So obviously I can use that conditionally to use features when they're available in later versions, but not cause my scripts to upset people using older versions. Remember we spoke about the with command a while ago, and actually prior to these setting convenience variables, that was a real struggle actually. If you wanted to set something back to what it was before, well, now I can just use with, but I might want to just detect and do something different depending on what the settings are. So I can GB setting if I go pagination. Cool. So it tells me pagination is on. So set pagination off. If I go there again, I can see 0 for off. I can also get these as a string. Like that. So that you can imagine, how that could be quite useful when building scripts that you want your users to import. And then lastly, some little convenience variables here. Shell exit code. I mean, probably pretty obvious what they mean, but well, maybe not. So there's the shell command, right? So I can go shell cat. Whoops. Oh, it doesn't exist, of course, I moved it. But all right, well, that's, even though I was going to, so shell does what you might imagine, right? It's going to run a shell and run that command in that shell. And let's do it. Proc self maps. Oh, look at that. And if I echo, not echo, these are print, sorry, print. Shell exit code, let's go to 0, and I was doing my hello.c that doesn't exist. Cool. All right. So that again, if I'm shelling out things, particularly as part of scripts that I'm defining, that can be pretty useful. Yeah. Right. So a couple of bigger things now. Well, this one's gonna be fairly short. I just there's an error in my slides. I think these symbol worker threads are optional in V10 and by default in V11. Apologies for that. So remember, I've said like a little forewarning of this, foreshadowing of this when I talked about the Firefox symbols. So if using so remember, this is just the default GDB on my system, which is GDB 10. I think I have the Firefox running. No, I don't. All right, let's run. Let's start up a Firefox. There we go. Right, minimize that. So now, oh. Yeah, all right, so it's actually called Gecko main, it's Firefox. So if I GDB-P to this PID, remember I've installed my Firefox symbols. So here we go. My fans are whizzing up now, and actually I can go htop and we can see, yeah, it's really busy. One of the CPUs pegged at 100%, seems to have switched around. Still doing a whole bunch of work. There's a lot of symbols for it to slurp in. You can see it's basically some background stuff happening, but I've got one CPU pegged at 100%. If we wait, it'll finish. Eventually. Still waiting. There's lots of symbols for it to figure out. There we go. It's done it. Okay, so that took me, what, 30 seconds? Felt at least that. Always feels longer when you're doing a demo. If I do the same with GDB 11, boom, look at that. How much quicker was that? I think it's so much quicker, actually. There's only 8 CPUs on this machine. It's so much quicker that I think something else, there's been other optimizations. It's not, I think it feels like more than 8 times quicker. But it will spawn up multiple threads and just process all of the symbols in parallel. Maybe get more than 8x actually, because it's IO bound. So maybe that is just a parallelism. But for whatever the underlying reason, that is way quicker to attach. So if you've got, if you find that attaching GDB to your large processes with lots and lots of debug information to crunch through is tedious, then GDB 11 is your friend. Or you can actually set the worker threads to be unlimited on GDB 10. So why don't we actually just try that? But I don't know. I'd have to set that. No, I'm not going to try that. But we should. Yeah. But anyway, so it's on. So yeah, as I say, this is. Let's edit that 5. So, oops. Option would be 10. Default in V11. Here we go. Right, I'm seeing loads of good little tips go by in the chat. By the way, this is great. I can't really keep much of an eye on the chat, but hopefully I can get access to it afterwards. Yeah, right. GDB 11 for the win if your programs are big. Right. Python 2. So in the poll, not that many people use Python, but quite a lot of people use 2e at least some of the time. 2e text user interface mode. We just saw that. We saw me using that earlier. I tend to sort of have it really switch into TUI mode by going Control XA, but there is another sort of slightly less weird way of doing that, which is layout source. Okay, now this has been around for ages. This is certainly not a new thing, although it is very useful, and I find, particularly given how useful it is, under known about, right? It's this thing again. GDB is not very discoverable, but you can watch my earlier and other people's talks to learn about the existence of text user interface or TUI mode. But it's in the later in GDB 10 and even more so in 11. It's more you can actually sort of start to customize it. So we can actually define our own layouts. We can define our own layouts, and we can define our own windows using the Python integration, and then you can start to do various cool things. So let's have a look at yeah. So this is my really. So what I'm going to do here is define my own window class, which takes a constructor and has this render method, and then I've got a factory factory class that I can pass into GDB. So I'm going to use something inside GDB called something in the GDB Python integration to register a new window type. So let's go over here. Let's turn TUI off, go back. So this is my, so I do this by having a factory function that will create this object, as you can see here. So, and I do that by, just a second, refer to my notes because I don't quite remember all this stuff. Right, so Python GDB dot register window type. I'm going to give that window type a name. I'm going to call it blah, and I'm going to call it I'm going to give it the factory function that I just defined. Of course, that's not going to work because I didn't source that file yet. No, so whoops. So source like that. Now I should be able to define that. Cool. Right. So now I've registered a window type. So window type blah. It's going to call that bit of Python to create my factory window. And now I need to define a new TUI layout mode, right? So TUI, so I have a bunch of layouts. I can just do this by, if I go tab, these are the different layouts that I could choose, right? Layout source being the most commonly used one, I think. But I'm going to make my own layout, and I'm going to call this CppCon demo, and then I need to give it some window types. So we just defined a window type called blah. So let's have a blah window. Let's have that be 10 lines long. Then I'm going to have my source. This is inbuilt. So I'll have, let's say, 20 lines of source. Have to have, when you define one of these layouts, you have to give it a command window. Otherwise, you kind of, saw off the branch you're sat on. So if I try and do that without command, I think it'll tell me, no, you can't do that. Let's give a command. So that's my new TUI layout that I've made. So now when I go layout tab, oh, look, got a new one's appeared. And so when I go CppCon, it should autocomplete. Yeah. Look. So now I've got this, I've got my source window, then I define my command window down here, and I've got my blah window that I put up there. So you can start to imagine how I could do various cool things with this to be really helpful for my project. In fact, you can go, we can do a bit more with this one. So this is, I've actually defined here, still got my render function, but I'm actually going to read in some. Well, I'm going to read in this actually. Let's get that. So I've got more lines of code. So this is kind of the same, but I've just added in some stuff. It's going to read in itself and display it. Oh, I get that right. I've implemented this click function. I've implemented this vscroll function as well. So it's just kind of scrolling around whatever I'm looking at. The rest of it looks kind of the same, but I'm going to just source these register window type commands just so I get it right. So let's try that again. And now source to E2. And oh, it's probably not quite what I had in mind. Let's make that a bit bigger. That's not doing what I wanted it to do. Oh, I tell you why not, because I'm running the wrong version of GDB. I need to be running GDB 11 for this stuff. There we go. And now you see, if I move my mouse up to the top window here, I'm not sure. Can you see my mouse? I'm not quite sure what gets. I don't think you can. Anyway, my mouse is pointing inside the top window here, and when I scroll down, it's responding to those scroll events, and so just a nice little bit. And when I click it, it's just got a little click printf there, so you can see where exactly I've clicked. So you can sort of definitely imagine how you could build all kinds of cool stuff in TUI mode. And it's kind of pretty configurable. So obviously you can do lots of neat stuff if you're using Emacs or VS. Some comments going behind VS Code. You can do all kinds of neat stuff, but it's quite simple to get going, I would argue, this stuff in TUI mode, and it's got the advantage that you don't need anything else present to use it. So yeah, right. That's pretty much all I wanted to say on that. There's some small improvements. I can't quite remember what they are, but the compile command, and this is a new one to me. I didn't actually know. This has been around for a little while, but I didn't know it existed. And what you can do is compile some code and inject it on the fly. So so let's have a look. So print x.a. Well, okay, it doesn't quite exist yet, I suppose. So let's make that object exist. Print x.a. Okay, find one. I'm not initialized, so it's set to whatever. So I can go compile, and then I can set x.a equals 42. End. Why has it done that? I think that's because that's a slightly balked version of GDB. Let's do it again. Start. Right, print x.a, compile, x.a equals 42, end. And now, look at that. So it compiled a little bit of code, injected it into my program, and ran it for me. So that's kind of neat. Now, obviously, I could just go, don't need, that's maybe a slightly bad example, because I can go set x.a equals 4, and that has the same effect. But obviously, with that compile command, I can do all kinds of stuff. So that's quite nice. And to be totally transparent, I cannot remember what the small improvement to compile was in the later versions of GDB, but I figured it's probably not, well, I guess a lot of people didn't. I'm assuming people don't necessarily know about it. It's certainly not something I've spoken about before, because I didn't even know about it. But yeah, isn't that cool? And I think this is my final little bit, but this is a C++ conference, and I often and quite fairly get brought up for not doing much C++ specific content, which is fair cop. So let's break the habit of a lifetime and do some. So here's a little bit of C++ code which defines a function foo and overloads it based on the arguments that you pass in. Right? Okay, fine. So if I run an older version of GDB, I think 9 will show this. Well, let's compile it first. Whoops. Minus G3. I always do G3. GDB out. So, right, so now I'm going to put a breakpoint on foo. Now it's actually done it on 2 locations, right? Because there are 2 foos, that's fine. So break, yeah, so breakpoint 2, it's breakpoint 2, by the way, because I did start, which did a temporary breakpoint 1. So it's my second breakpoint. And it's actually got 2.1 and 2.2 for my 2 different foos. That's fine, right? Nothing to write home about. Let's delete all those breakpoints. But what if I wanted to say break foo if, and I mean, the more I use GDB, the more I find myself doing conditional breakpoints because they're just super useful. And let's just see. Okay, let's go code. So I've got my 2. I take something called x. So if I go break foo if x is more than 0, it doesn't like it. It doesn't like it because it tried to set that condition on both foos. Same if I go break foo cond 3 x is more than 0, still doesn't like it. I can probably go. No, it doesn't even like that. Ha, didn't know that. So yeah, look at that. Can't even do that. Now that's GDB 9. No, that was GDB. Sorry, that was GDB 10. So this is fixed in GDB 11 then, I think. So so now, so I'm going to go break foo if x more than 0, and okay, it's giving me a warning, but it has done something, and it's set it. So now info break. Look, I've got same as before, 2.1 and 2.2, but yeah, 2.1 and 2.2, but 2.1 is this, but it's got this condition, and so on 2.2. I can see it is it's disabled, right? The breakpoint is disabled because the condition is not valid there. So that's a nice little, I think it's a fix, really. So we are, as the chat says, running out of time, but that is quite convenient because I've also run out of content. So I think that is the end, yeah. So so access from, so yeah, so we've still got time to do Q&A in the chat if there's any questions. We've got a few minutes left. There are questions in Q&A. I'm looking at the chat. I should be looking at the Q&A. Thank you very much. Where is the Q&A? Too many windows. Right. And oh, hang on. Oh man, sometimes Zoom is a bit. Zoom is defeating me because I moved. Yeah, I'll tell you what it was. I moved the. Hang on. Got way too many windows open. Where does that go? I moved the little Zoom window because it was getting in the way. Now it doesn't exist. Hang on. See if I can find it from here. Polls chat. Yeah, we might. Hang on. I've got another. Here we go. I've got it. I've got another one open here. So, okay. So first question, yeah, was I guess related to Debug Info. I'm going to go in reverse order if that's all right, because I think it's going to make sense. Are print frame arguments and ptype supported on non-ELF platforms? Don't know, to be honest. I would have. I mean, but I'm going to take a guess, right? Because I'm kind of bold like that, and I think if the Debug Info on that platform is capable of printing out structures, then I think I would expect that to work. So yeah, as long as your debug info is reasonably sane, I'd expect print frame arguments and ptype to work. But you'll have to try it and let me know whether it does. Any fixes for GCC 9 for AIX COF support and Spark v9 Solaris? Not as far as I am aware. I haven't checked everything in detail, but no, I don't know of any. I don't think I saw any changes in the change logs there. Next question up: can you comfortably test custom GDB scripts? Not sure I understand the question. Okay, so we are running out of time, so I think that's time. So we're going to move to GatherTown, which I've not used before, but hopefully it'll all be simple enough. So I'm going to click over to GatherTown, and we can continue any discussion there. Thank you very much, everybody, for joining the talk. Thanks for the great questions. Hope we can ask some more of them. And just a shame not to have been there in person. If this conference had been just a couple of weeks later, or the rules had changed just a couple of weeks earlier, I could have got over there and done this live, and we could have, those of us live could have been together. But hey, that's the world we live in now. But hopefully next year we'll be there live. All right, I'm going to head over to GatherTown, see if anyone wants to hang out there. Right.